guys, how are you doing? I'm Ashi and this is a new episode of Clean Code Developers. I would like to explain how to launch AWS instances for use with Kubernetes in this episode. Minimum requirements for instance type of a node in Kubernetes are 2 CPUs and 2 GB RAM. Let's get started. To work in AWS console, you need to have user. The main user is the user that creates the AWS account, that AWS names that the root user, and that root user can assign and create another users by using the IAM service, identity and account management. But let's say we assume we created that users and with any permissions we need, and we will continue with EC2 part. Before we start, you need to consider that if you use any service in AWS, AWS will charge you for it. For example, when we use EC2 services, AWS will charge us because we are consuming AWS resources, even if we stop our virtual machines. The first step is creating masternode instance on AWS. To do this, we can click on Launch Instance in EC2 dashboard, or come inside the instances part and click on Launch Instances. I click here and goes into creating the instance part. We can enter here the name of our instance that shows inside our the instances list. So I enter master for that. We need to create master and worker nodes, and I am creating the master node now. Then you can choose a operating system that I prefer the LTS version of Ubuntu for our purpose, that it is 2.4.04. Next step is select an instance type for our master node, including our minimum requirements, 2 CPUs and 2 GB of RAM. That the minimal one is this item that include 2 CPUs and 4 GB of memory. The next item we need to select is a key pair. I have created already a key pair for my Kubernetes nodes, so I select it, and you need to know how to create this part. Please pay attention and find it to check how you can create this key pair and download the file you need. Leave the rest items with the default selections. We will update them if necessary in next steps. The final step is clicking on launch instance. I click on it, and yeah, it's created my instance. Now if I go to instances part, I can see my instance created. It is in initiating a step, so it's creating in fact our instance, and after a while this will running. Yeah, it's changed the state to running, and now we can select the node and connect to our instance by several ways. It gave us the way I am using to do this is using this command that related to the key pair I have created and downloaded earlier before this creating this video, and connecting via command prompt or any commander application you prefer, and working with EC2 instance. Let's create a key pair for the EC2 instance we want to create. Assume we opened the part we want to launch instance, and in this part we can create new key pair. I click on create new key pair. I can select the name for that, for example K8s test. This is just for test, and I have created once before, you know. I use RSA encrypted type because it is a normal one. Usually everyone use it, and it's more secure one, and it's one of the best. And for file format, we keep the default value as PM. I create key pair. I click on create key pair, and after that it will download the file related to that key pair that you can see inside the downloaded part. Now you can see here the key pair name K8s test that we created already. That's all for creating a key pair that we need to launch our instance and connect to our instance. Just keep in mind that you need to keep in a safe place this file, because you need it to connect to your EC2 instance. The next exciting step is creating a worker node instance on AWS. Click on launch instances in EC2 section first, and you can enter number of instances here. It is useful when you want to have several instances with same configuration, but for now I just keep it on one instance and just enter worker for my node name. When you create several instances, you can leave it empty, and after finishing the setup of your instances, you can change the instance name in the list of instances you have in your EC2 instances dashboard. The next step is select the operating system that I use, the latest LTS version of Ubuntu with 64-bit architecture, and after that we need to select the instance type for worker node one level stronger than master node configuration. Or master node was 2 CPU and 4 GB of RAM, and for our worker node we use 2 CPU and 8 GB of memory, because worker nodes use more resources than master node, because your workload apply mostly on your worker nodes. Master node run the services you need for Kubernetes, but user use worker nodes to use those services on Kubernetes. The next step is use or create a key pair that, as you know, we have already two key pairs, K8s node and K8s test, that I choose the main key pair I created earlier, and after that I just keep the rest of configuration and leave them, and easily click on launch instance. It created successfully, initiated, and then I go to instances part. I can see the worker node is pending to create. After a few seconds, it will change the state to running state, and like the master node I showed, we can connect to worker node. As you can see, it's running now by clicking on connect and use this command in your commander, your favorite commander. Easily you can click on copy button and use in your commander and connect to your instance. If you plan to use an SSH client on a Linux computer to connect to the instance, move private key to .ssh folder by this command, and use this command to set the permissions of your private key file so that only you can read it. I don't need to apply these permissions to my key because I use Windows to connect to the instances I have created. So as you can see here, I have two commander tab, one in master operations and another one in worker operations. Both of them is in one place. The place, I mean the path that my key pair is placed in. If I type ls, you can see that my key pair is in this path. So I'm gonna connect to master instance first. I click it, copy the command. I can connect to my master node. Easily I paste it here, and after that just I enter yes, and I get into the master node instance. Here we don't have any folder. If I go one folder up, then you can see we have Ubuntu username here that we log in with. The other one is our worker node, that if I want to connect to worker node, I click the I copy this command. I then go to worker operations tab in my commander and paste the command I copy from the instance section in AWS and enter. As you can see, you need to enter again for yes. I mean enter yes here because it is another instance completely that you need to connect to with completely different address. And after that, yeah, we connected to instance here. As you can see, we don't have any folder here, and if I go up one folder, you can see again we have logged in with the Ubuntu user, like the another instance we have, the master instance. So if you want to log out from this instance, these instances, you can easily simply enter exit. You will exit from instance and exit from commander, and again here also exit and exit. That's all. We need to disable swap on all node instances we have created. We can open the installing kubeadm documentation in Kubernetes official website and check the section before you begin. to swap off the instances. You can see the complete instruction here about what you need to do about swapping off the node instances we have. So we need to go to folder up in both instances we have. I will do this first on master node. As you can see here, I go to folder up and then open fstep file to disable swap permanently with vim command. I opened it. Then you need to search the swap to find the line containing swap, like this. But as you can see, there is no any swap word inside the inside this file. If we find the swap in this file, we need to comment by adding a hash sign in starting of the line. Then reboot the system in order to apply the new swap setting. You can reboot your instance by clicking in instance state. You select your instance state and reboot instance. It will reboot your instance. But because we don't have the swap configuration in our file, we simply just execute this command. Also, we do same in worker node. Open the file and again search the swap word, and again you can see we couldn't find this. So we exit the file without saving anything, then execute this command for worker node 2. That's all. The reason we need to swap off node instances we have is explained here. You must disable swap if the kubelet is not properly configured to use swap. Kubelet, kubeadm, and kubectl are Kubernetes components that you can use to ease the configuration and execution of the Kubernetes commands inside your environment. The next step is set up ports for master node instance. To do this, select master node in EC2 instance list, go to security tab, click on security groups item, then click on edit inbound rules. We need to enter several inbound rules. Click on add rule. For each rule you need to add to inbound rules. Select custom TCP for all of them. Go to Kubernetes documentation, the ports and protocols section web page, and follow ports in control plane section. As I prepared it already, you can see the part related to this section. We need to enter port number or port range inside the port range input here when we want to enter the ports. To enter all these values, we use custom TCP value for type section. For all, we need to enter this port range, and for source part, we select anywhere IPv4 with this IP address, because this needs to be accessed by every IP address from outside. For rest of inbound rules, you need to have IPv4 CIDR of current cluster, since there are no need to access from outside. You can find cluster IPv4 CIDR by click on VPC item for the master node and use the value in IPv4 CIDR column. I wait to open the screen related to the VPC ID, and then select the IPv4 CIDR from here. For Kube API server and etcd, we enter this port range. Beforehand, we select custom TCP, as I mentioned earlier. I copy this port range and enter in port range here. Select custom IP, because we want to enter IPv4 CIDR here. I copy this value and enter here. Yeah, that's all. For self and control plane, I need to enter custom and the IPv4 CIDR of VPC. Then I copy again and enter here. We keep the custom TCP value selected here and enter the port related to Kubelet API for self and control plane part. Then we need to click on save rules to save the rules we defined, and based on the message you can see here, the inbound rules successfully modified for the security group. Then we can change the security group name inside the security group list. As you can see, this is the security group we have, and we update the name to master that's related to our master node inbound rules. After completing inbound rules for master node, we go to this web page to find the inbound rules for worker node, and we need to enter this rule and this rule for our worker node. Come to EC2 instances screen. I select worker node. After that, select security tab and open the security groups for worker node in new screen. Then I click on edit inbound rules. After that, I click on add rule. For all inbound rules, I select the anywhere IPv4 in source part, and then enter the port range we need to use for all. It is anywhere IPv4 and the IP like this, because it needs to be accessed by outside of the node. So we enter this, we use anywhere IPv4 and this IP address as source, and enter the port range mentioned inside the web page. After that, we add another rule with custom TCP and enter the port range for self and control plane. Then we use custom value and the IPv4 CIDR for or worker node that I showed you how to access this. We come to this screen and select worker node. After clicking on VPC ID, it opens the screen related or VPC ID. After loading, we can find the IPv4 CIDR value here. Copy this value from this screen and paste it inside this item. So for source we have custom and this IPv4 CADR value, this port range and custom TCP. That's all. We have only these two inbound rules for our worker node. We save the rules and after that we go to the security groups part and select, we go to the section, we have the security ID and we update the name of the security groups we have to worker. Maybe you notice that when we log in inside our instances, we see the IP addresses of our instances in master and worker node. We can insert a command, use a command to change this in both sides, master and worker node. We enter this command, come inside this place, and for the first part we copy the private IP for our master and come inside here and press I to insert our document here. Then we insert the IP here that we copy from AWS. Then we enter master and for our worker node also we copy the private IP address and then come inside here and paste here as worker node. Then we need to press escape and WQ to save and exit. We will do same for worker node and do it here. Come inside here, press I to insert or text, then master, and for the next one for worker. Then press escape and again WQ to save and exit. Now we exit again from here and from master node. When we want to apply changes, we need to exit and return back again. But for now I will connect the master once again. And I need to enter another command here. So I will enter a command to set the master node name to master. This one for master node, and for worker node I need also connect to worker node and enter the command. Like this, and enter the command here. After this, if I exit and come back again, I can see the names are changed to
the names we set in those commands. I will come back for my master node and see here it's my master node, and the other one, the worker node, you can see it's worker. Okay, I hope this part would be useful for you if you want to use Kubernetes and define your master and worker nodes on AWS. Until next chapter, stay tuned.